What if I told you that a computer can understand your language, your sentiment, even read between the lines? Yes, all these human-like capabilities that we didn't think possible a decade ago are now a reality, all because of large language models, LLMs.
That idea itself is mind-boggling, isn't it? Machines, which were once infamous for their literal interpretation of commands, now possess this impressive ability to comprehend and even mimic human language. And it's not just any random evolution. It's a result of painstaking planning and a technological revolution in AI.
Right, Olivia. In the early days of AI, computers didn't really understand human language. Take, for instance, the ELIZA program developed in the mid-60s at MIT. It mirrored a psychotherapist, but the responses were pre-programmed. It didn't understand the user at all.
You might be wondering how they transformed from that to the power of understanding context, sentiment, and even generating a human-like text.
Well, the credit goes to countless researchers, companies, and of course, the development of language processing models like LLMs. Today's large language models like GPT-3 are miles ahead of their predecessors, with a better comprehension of human language and increased generative power.
And to think it all started with simple tasks like word predictions in your text application or autocorrections. The leaps and bounds AI has made over decades seem like out of a science fiction novel.
The journey isn't complete, though. There are still challenges that stand in our way. But if there's anything history tells us, it's that no mountain is high enough when armed with innovation, determination, and curiosity. Large language models, or LLMs, are truly getting us closer to having AI that can communicate like a human. But what really makes them tick?
I think it's critical to first understand that they're built on the principles of machine learning, just more sophisticated. LLMs are trained on extensive corpora of text data, which can be anything from books and articles to websites and scripts. The more diverse, the better.
Right, and the fascinating part is how they derive meaning. LLMs create numeric representations of words, using context to understand and generate language. This is a departure from rule-based language processing methods of the past.
Can you guys simplify it for me? I understand the basics, but how exactly does an LLM learn?
Okay, let's take it slow. So when training an LLM, we start with a large corpus of text. Each word, or sometimes even parts of words, converts into a numerical representation, a vector form. This preserves the context within the text corpus.
And then these models predict the next word in a sentence. They get more accurate with an increasing amount of data. Can you imagine? They're essentially learning language patterns from billions or even trillions of words.
Exactly. The model continues to adjust its internal parameters based on the prediction errors it makes. And over time, the model becomes very good at predicting the next word, understanding context, and generating coherent response.
Sounds like a trial and error method to me. Quite human-like, isn't it?
Yeah, it's almost like how a child learns, from constant exposure to language. More exposure leads to better understanding. It makes me wonder, do these models eventually learn to mimic human-like traits, given enough data?
A thought-provoking question, and one that we'll delve into deeper. LLMs have certainly come a long way, and there's still a journey ahead. Now let's try to grapple with the machine learning part at the heart of this LLM idea. So at the base level, we're using a form of machine learning called unsupervised learning.
Unsupervised learning? How does that work?
Imagine you have a kid, and you want to teach him or her to differentiate between dogs and cats. In supervised learning, you show the kid pictures of dogs and say, "These are dogs," and then pictures of cats and say, "Those are cats." But in unsupervised learning, you just put the kid in a park filled with dogs and cats. Over time, the kid makes out the difference just by observing characteristics.
Right. In a practical sense, that's what happens during the training of these LLMs. The model goes through a copious amount of data, trillions of words, and starts distinguishing language patterns in the corpus. It becomes capable of predicting the next word of a sentence, understanding nuanced contexts, and generating human-like text.
The goal here is optimization. This is a process by which the model constantly adjusts its internal parameters, so it gets better at predicting outcomes. And the key to successful optimization: high-quality, diverse data. The better the data feed, the more the model learns.
So, is this where LLMs differentiate from other machine learning models?
Not entirely. While their use of large-scale unsupervised learning is a defining factor, the real difference lies in their ability to generate language that's almost human-like in its representation of knowledge, reasoning, and even a degree of creativity. This conversation-like aspect is what makes them unique and powerful.
When we think about practical usage, Google is a key player. Their BERT model serves as the bedrock for many search queries. Any ideas on how that works?
Absolutely, Olivia. Google uses BERT to understand the context of words in a search query. This means that Google Search can now better understand the intent behind your searches. For example, if we search for tips to grow indoor plants, Google will understand that we are seeking advice on nurturing houseplants, not just raw information on indoor plants.
That's fascinating. So the application isn't limited to simple question-answering tasks?
You're exactly right, Jiwoo. The range extends far beyond that. For instance, consider Google's server called Mina, which is used in a conversational AI model designed to chat more naturally with us humans. It's specifically designed to go beyond understanding and answering to actually hold multi-turn conversations.
In a way, it's like teaching language to computers.
Exactly. In fact, OpenAI's GPT-3 model has been making headlines in this domain. It can write poetry, translate languages, or even generate functioning computer code. It's like commanding the essence of different professions inside a software program.
Incredible. How about Facebook? They're a big player as well, right?
Indeed, Facebook uses artificially intelligent models to translate user-generated content across different languages, opening up wider interaction possibilities for its global user base.
Actually, let me stress this. Isn't it fascinating how LLMs have even forayed into the medical field, for instance, in transcription services?
Yes, Jiwoo, you're absolutely right. They're now being used to convert doctors' spoken words into written reports. This significantly reduces the effort needed for manual transcriptions, which can be quite time-consuming and error-prone.
Wow, that already seems like an incredible help. But I guess their biggest contribution is in the enhancement of speech recognition technology, isn't it? Because that's something we interact with on a regularly basis, whether with our phones or home assistants.
Definitely, Olivia. LLMs have revolutionized speech recognition. By understanding the context of our commands, these AI models are able to respond in a more intuitive and human-like manner. These systems have now evolved to the point where they can transcribe spoken language as well, or even better than human transcriptionists. It's this decoding ability of LLMs that's driving the progress in this field.
That sounds almost surreal. But on the flip side, what are some limitations we currently face in all these practical use cases of LLMs?
Well, one key limitation is that these models can sometimes make mistakes that a human never would. This might be due to skewed training data, or simply because LLMs don't possess human intuition. Another issue is that LLMs are not always transparent in how they come to a particular decision. This so-called black box problem can be a major challenge in fields like healthcare, where understanding the reasoning behind a decision is critical.
Very well pointed out, Olivia. These limitations certainly put into perspective the potential and challenges of LLMs. While they can indeed be very powerful tools, they almost always require careful calibration, close monitoring, and continuous refinement. Coming back to our main theme for today, let's look at another unique area where LLMs shine: natural language processing, or NLP.
NLP, if I remember correctly, is essentially about making computers understand and generate human language, right?
Exactly, Olivia. And LLMs are playing a pivotal role in evolving NLP. Chris, could you delve into exactly how?
Sure, Jiwoo. At its core, NLP is about breaking down language into shorter, elemental pieces, understanding their interactions, and using algorithms to understand and generate language. LLMs, by their function, are perfectly suited for this task. By training on large datasets, these models learn context, grammar, and even world facts. This allows them to answer queries, translate languages, auto-generate text, and even simulate chatbots.
So if I'm getting it right, LLMs are fundamentally transforming how we interact with technology. Instead of us learning how to communicate with machines, the machines are learning to understand and mimic us.
Yes, Olivia, that's probably the most significant change, like how chatbots, powered by LLMs, can help automate customer support, making it real-time, more accurate, and cost-effective. Or, think about the assistant in your phone, able to not just understand your voice commands but also engaging you in more nuanced conversations.
Also, let's not forget about sentiment analysis. It's all about figuring out the emotional tone behind words. And this is crucial when it comes to industries like marketing and public relations, correct?
Very correct, Jiwoo. LLMs, with their ability to understand context, can identify whether a text is positive, negative, neutral, and to what degree. This can be incredibly useful for businesses to, say, evaluate customer reviews or to monitor social media sentiment.
Now, the role of LLMs doesn't stop at translation or even sentiment analysis. We're seeing their applications in some pretty advanced areas, like linguistic research. Isn't that right, Jiwoo?
That's right, Olivia. Linguistics, the scientific study of language and its structure, is another area where LLMs are making a mark. Take morphology, for instance, which deals with the internal structure of words.
Morphology analysis is one complex task, Jiwoo. It involves determining the root form of words, their inflections, and other related forms. It's a daunting process for a human, let alone a machine.
It's indeed a challenge, Chris. But with LLMs, we're seeing a remarkable progress. Because they're trained on massive datasets, they can learn typical morphological patterns and apply them to words they've never seen before. This can be a huge advantage in understanding complex languages with myriad word forms.
So, if I understood correctly, LLMs are lending a helping hand to understand not just languages more generally, but the intricate underlying rules that govern them. And if that's the case, it seems like LLMs can potentially revolutionize linguistic research.
Absolutely, Olivia. This capability of LLMs may contribute to breakthroughs in research areas like psycholinguistics, neurolinguistics, and even sociolinguistics. Imagine the potential.
Not to mention, such applications reflect the flexibility and the versatile capabilities of LLMs. It's not only about recognizing words and generating coherent sentences, but also about understanding the complex rules that shape languages.
As we explore the capabilities of LLMs, we must also shed light on potential concerns. One of the main issues surrounding these models is biases, pervasive in our society, and hence in the data LLMs are trained on. Olivia, how do you perceive this from a content creation perspective?
That's a key question, Chris. With LLMs generating content based on large amounts of data from the internet, there's a real risk for them to pick up and potentially amplify harmful biases. This could fundamentally influence how people perceive and understand the world.
I agree, biases can indeed have a substantial impact. But what about privacy concerns? These models, as we know, get trained on significant amounts of pre-existing text. Chris, from your understanding, are there any real privacy threats?
Well, Jiwoo, theoretically, LLMs should not be able to recall specific documents or sources from their training data. However, the broad access of major LLMs to data raises questions around privacy. For instance, how are they ensuring removal of private and confidential information from their training data?
Yes, and beyond privacy and bias, an equally significant concern I see is around equitable access to technology. As LLMs advance, how do we ensure that this technology is not just benefiting the already privileged sections of society?
I share that concern, Olivia. The ethical implications of AI, particularly LLMs, are not straightforward and present varied challenges from fairness to transparency. As ever, it's crucial that we approach progress with thoughtfulness and responsibility.
Agreed, Jiwoo. In all, it seems that while LLMs have immense potential in heralding a new era in AI, their path is illuminated by caution signs, biases, privacy, equitable access. But with balanced conversation and robust regulation, we can navigate this path towards a future that balances advancement with ethics.
Besides the risks we've discussed, another pressing issue is the lack of comprehensive regulations for LLM use.
Right, Olivia. As the utilization of LLMs increases, it's critical to establish firm legal frameworks that govern their usage and impacts.
Indeed. But what are the main aspects these regulations should cover, and how can we ensure they're fair and unbiased?
There are several facets to consider. First, transparency. It's important to know how these models work, including where they get their training data, how they evaluate results, and so on. This isn't to say all algorithmic details should be revealed, but the necessary functional and operational information would allow users to make informed decisions.
Additionally, privacy and data protection need to be ensured. As LLMs use a vast corpus of data for training, any regulatory framework must have strict rules on what data can be used and how it is stored and handled.
That's correct. We should also ponder about guarding against misuse. As powerful tools, the misuse of LLMs by rogue elements or dictatorial regimes can cause severe harm. Regulating access to high-quality models might be one way to approach this problem. What is your take, Chris?
Agreed, that's another essential point, Jiwoo. Also, let's not forget about the economic and accessibility implications. We want to ensure that not only the highly resourced organizations or countries benefit from this technology, but that it is equally available to offer transformative opportunities globally.
And perhaps, it won't hurt to contemplate on processes that ensure the ethical use of AI. It could be certifications, audits, or perhaps some form of ethics boards to review applications of large language models.
Definitely, Olivia. The challenge, however, is to make sure that regulation facilitates innovation and not hamper it. It's a delicate balance, but one we need to strike to navigate the future of AI ethically and effectively. Let's delve into our future with LLMs. What do you both foresee as forthcoming advancements with this technology?
I'd love to see LLMs tackling creative problem-solving in the design field. They might predict and solve design issues that human designers often overlook.
Building on that, Jiwoo, LLMs might redefine creativity itself. They could generate written content indistinguishable from human creation and even evolve to produce visual art.
With such versatility, we might expect a significant impact on job markets. However, could this also pave the way for a knowledge and skill shift rather than job displacement?
That's an optimistic view, Chris. Technology has always been a double-edged sword. While LLMs could automate and optimize many job tasks, they could also demand new expertise and create novel professions.
Yes, jobs like AI ethicists or LLM trainers could gain more prominence. But, in terms of research areas, I wonder what's next. Are we heading toward a more holistic language understanding or something more specific?
Good question, Olivia. We might see more efforts in scaling up the models, but I also anticipate increasing research on making LLMs more interpretive and transparent.
That leads us inevitably to ponder about LLMs and AGI. How far are we from AI that profoundly understands and generates human-level language?
Developing AGI is a grand challenge. Although LLMs demonstrate impressive capabilities, they are not cognizant of the meanings they generate, and that's a key aspect of AGI.
Yet, with the pace of progress, who knows what the AI horizon holds? We might be closer than we think.
The sheer complexity of LLMs can really make you marvel, right? Pre-training, fine-tuning, tokenization. Want to dive into these, Olivia?
Well, let's start with pre-training, which is basically where the model learns patterns in the data before it's tasked with a specific job. It's akin to a baby learning language cues from its surroundings, right, Jiwoo?
Yes, and after pre-training, we have fine-tuning. Suppose the pre-trained baby AI has grown. Now it needs to perform a specific task, like understanding medical transcripts. Fine-tuning is where it's trained with specific data relevant to the task. Tokenization, though, seems a tad more complicated.
Tokenizing a sentence means the AI sees it as a series of tokens. These could be whole words, or even smaller units depending on the language. And these, in essence, form the input for our language model. But this process can become complex as languages have their nuances, right?
Absolutely, and to handle these subtleties, there's the attention mechanism. It enables models to focus on different parts of the input sequence when generating an output. It's like when we speak, we focus on various things: emotion, tone, context. The attention mechanism is a mathematical equivalent of that.
Such intricacy, but isn't a part of their functioning still a mystery? This whole black box problem. Can you shed some light, Chris?
The black box problem indeed encapsulates the challenge of interpretability in AI. While we understand the input and the output, the path in between can be murky. We lack methods to understand why and how the model makes a specific decision.
That's a tad unsettling but also intriguing. We've created something that can outperform us, but we can't fully comprehend it. Makes you wonder, doesn't it?
Remember how we talked about LLMs interpreting sentences as series of tokens? Well, being bilingual, I once experimented with one, typing English and Korean sentences interchangeably. Unexpectedly, it kept a reliable track, and the conversation turned out to be informatively fluid.
That's such an interactive test of LLMs. I must admit, though, my interactions with these models have mostly been content recommendations. Tracking my reading habits, particularly books, has led to some genuinely great suggestions. It's like having a personalized AI librarian at your service.
Interesting. Blends of culture and suggestions, great touch points. Have either of you ever used an AI-powered personal assistant? I had a chance to while collaborating with an international team for a project. The bot was set up for scheduling, and boy, did it eliminate all the back and forth of finalizing meetings across multiple time zones.
I can see how that could be a game changer. However, my most memorable interaction was while coding. I used a LLM-based coding assistant to help debug and optimize code, and I was astonished at its suggestions. It really felt like a seasoned developer guiding me through the process.
That's fascinating. But can I share a fun tale? I typed a peculiar prompt. Imagine if dogs ruled the world, into one of these models, and the generated story was not just coherent, but downright hilarious. Oh, and it made sure every other sentence had a bark.
Ah, the AI humor, a whole different realm. These unconventional experiences bring us closer, understanding their potential and also the humorous side of it. I believe it adds to the charm and makes us wonder how far and wide AI can reach.
LLMs are receiving significant investment, right?
Indeed, OpenAI's success with GPT-3, a prime example of an LLM, attracted a lot of investor interest. It's a hot area, and there's a wave of startups innovating in this space.
So in a way, LLMs are turning out to be startup magnets. Has this led to the emergence of new products or services?
Definitely. Many startups are springing up, leveraging LLM tech to create AI-driven solutions, and investors are quick to back these novel ideas. My startup could certainly benefit from marrying our AI tech with LLMs.
Tech incubators seem to have a vital role in fostering this innovation, right?
Precisely. Incubators are nurturing these young entrepreneurs, providing them with essential resources like technical knowledge, industry connections, and funding, which all accelerates LLM development.
That's interesting. What areas or industries do you think will be most impacted by business innovation in LLMs?
Well, primarily, any sector that could gain an edge through enhanced human-computer interaction may see a big influence. Medicine, education, entertainment, and even law could be revolutionized.
And it's not just conventional businesses. LLMs have potential in the social sector too. Think about how AI can aid in public policy making, law enforcement, or social work. We're staring at an exciting and varied business landscape here.
Here's a question that came in from a listener. How does a company decide to use LLMs when considering their product development? Well, that's an interesting question.
It's going to entirely depend on their specific needs and resources. One of the main advantages of LLMs is their ability to grasp and generate human language, right?
Yes, that's correct. Businesses need to assess whether such capabilities would indeed bring value to their products. Companies might consider factors like high-quality speech recognition, high-performance aid in language translation, or an efficient customer chatbot. But, on the flip side, they must also consider the expertise required to implement these technologies and the associated costs.
And don't forget ethical considerations. Dealing with customer data involves various concerns about privacy and security. These are things companies should ponder before deciding to incorporate LLMs.
Great point, Jiwoo. We also received a question about the cost of training LLM models. So, Chris, what's your take on that?
The cost factor. Well, training LLMs is not a small feat, It requires massive computational power, which in a sense translates to high costs. Plus, the size of the dataset used for training also incurs storage costs. However, the potential payoff could be significant in many application areas, which is what makes it attractive despite these costs.
So it's definitely a balancing act, making sure the investment into LLMs results in a worthwhile return.
Precisely, Jiwoo. We're dealing with a high-risk, high-reward situation. Folks, we hope this clarifies some of your inquiries about LLMs. There's so much to explore in this rapidly advancing AI field, and we're here to help you navigate it. Thanks for these thoughtful questions.
As we wind down our deep dive into large language models, we hope you've gained a robust understanding of this important AI technology.
Absolutely, Chris. We've seen how LLMs have revolutionized numerous sectors from tech giants like Google to the medical field and translation services.
And let's not forget their contribution to natural language processing, from sentiment analysis and chatbots to linguistic research.
But along with that, we also discussed a significant aspect, the ethical side, the challenges of introducing biases, privacy-related issues, and the impact on access to technology.
That's so important. We always need to keep in mind the real-world implications of technological progression.
Exciting as these AI advancements are, we mustn't forget about the necessary balance with ethical considerations. Striking that balance is key for future growth.
And for those who want to delve deeper into the intricate world of LLMs, we'll be sharing some further reading resources on our podcast webpage.
Remember, AI is a journey of continuous learning and curiosity. Don't be afraid to dive in and see what you discover.
Now for a little teaser. Next episode, we'll be exploring another fascinating aspect of AI. Stay tuned.
We're all eager to venture deeper into the AI realm. Let's continue this journey, together, into the AI horizons. Until next time.